Hey everybody, can you believe it is the last week of distance learning? Woohoo! So we're going to continue with quadratic transformations. Last week we looked at what a does in our vertex form of our equation. F of x is equal to a times x minus h squared plus k. So we were looking at when h and k were 0 last week, and we were just focusing on a. What happens when it's positive? What happens when it's negative? What happens when it is a fraction that is less than 1, and what happens when it is a bigger number. So we saw vertical reflections over the x-axis. We saw vertical stretches and vertical compressions. So now we're going to look at h and k. So what happens when we have a number inside of here being added or subtracted to x, and then something on the outside of the parentheses added or subtracted as our k value. So again, remember our parent function, and as we saw last week, what this actually looks like, here's our table from squaring these numbers. -2 times -2 is 4, -1 times -1 is 1, 0 times 0 is 0, 1 times 1 is 1, and 2 times 2 is 4. So that is our table. We are centered right here at the origin. We have an axis of symmetry that goes straight through the vertex at the line x equals 0, right along the y-axis. All right, so what happens here? So the first thing that we're going to look at is h. And we are going to go to the left if our h value is less than 0. So this gets a little bit tricky because the negative is already in the formula. So we have a times x minus h squared plus k. And we all know that two negatives make a positive, and that's what's happening here. So for example, our parent function is this dotted one, and then this blue one over here is our transformed function. So it's 1, 2, 3 units to the left. And so how we would write that is y is equal to x plus 3 squared. And that's actually going to move us 3 units to the left. So technically our h value here would be -3. But when we plug that into a formula that already has a negative becomes a positive. So if we go to the right, we'll have an h value that's bigger than 0. So as we can see here, we're over at +3. So if h is +3, when we plug into our formula, it's x minus 3. So that part is kind of a little bit opposite of what you might think, and it's just because the negative is already part of our formula here. All right, let's look at k. So for k, this is going to be something that's added or subtracted outside of the parentheses. And when k is negative, this is, I think these are all 3, right? Yeah. This is -3 because we went down. So we would see this written as x squared minus 3. This one is up 3. So we have y equals x squared plus 3. This is not changing anything about the width of the graph. It's not making it skinnier or wider. It kind of looks like this inner one is skinnier, but it's only because we're just seeing the bottom part of it because it's moved up. We're not seeing all of it. It would obviously extend and keep going here, and it's actually just as wide. It just kind of looks like that just because it shifted and we're not seeing all of it. So we're not making anything wider or skinnier or reflecting with our h and our k. All we're doing is moving it up, down, left, right. But of course, we're going to add the a in because we already learned that last week. So let's go down here. Look at some examples. The screen's like spazzing. Okay. So sketch the following transformations, giving the parent function, identify the transformation. Okay, so we have x minus 4 squared. Is that an a, is that an h, or is that a k? It's an h. Remember, because our vertex form is y equals a, x minus h squared plus k. So our H value is actually 4, just 4, positive 4, because the negative is already part of, the subtraction sign is already part of the formula. So my H is a positive 4, which means I'm going to move 4 to the right. I'm not getting wider, skinnier, I'm not reflecting, I'm not doing anything like that. That's the ugliest graph I've ever drawn in my life. Because all we have is an H value. So we're here at 4, that's where my vertex is, and we'll try to draw a graph the best that we can. So we would say that this one shifts 4 units to the right. Okay, number 2. So we have an H again. We know this is H because it's inside of the parentheses with the X. And remember that negative is always part of the formula, X minus H squared. So technically my H value is -2, and we know that a negative negative makes a positive. So this means we're going to shift 2 units left. So I'm going to move my vertex 1, 2, and I'm not going to make my graph any wider or any skinnier. I just am really bad at drawing these today. Sorry. But it's the same shape, just shifted over 2 units to the left. Okay, next one. This is a K. We know this is K because it's outside. Well, there aren't any parentheses, but it's X squared plus 5. So this is a K. And so that's going to shift us 5 units up. So my vertex is going to be here at 5. And again, not any wider, not any skinnier. That's it. Just a regular width parabola. Just moved up 5. Here again we have a K, and our K is -3. So we're going to shift down 3 units. So I'm going to move my vertex down here to -3, and I'm going to try my best not to make it any more wide or skinny. It's just the same exact thing, just shifted down. Okay, and the last 2 are putting everything together. So we need to identify, oh, look at the numbering on here. This is number 1 and this is number 1. Interesting. Okay, so we have an A, we have an H, and we have a K. So we have 3 lines. My A is 2, that's out here in front, and that's going to be a vertical stretch. So I'm going to be skinny. My H is 3, and that's going to move me to the right. And my K is 1, and that's going to move me up. So I have to be skinny, 3 to the right, 1 up. So I'm going to move my vertex 1, 2, 3, up 1, and then I have to make it skinnier. Okay? I have 1/2 x plus 4, the quantity squared, minus 2. So my half, that's my A, and that's going to be a vertical compression, and that's going to make it wide. Technically, this H is a -4, and that's going to move me to the left, and my K is a -2, and that's going to move me down. So I'm going to be fat to the left and down. So 4 to the left, 2 down, there's my vertex, and I'm going to be more wide. And that's it.